Following is an excerpt taken from the third of 3 sessions that make up the 7-hour-long Module 5 training course on process piping design. This brief excerpt discusses a portion of the topic on piping flexibility. No formal analysis of adequate flexibility is required for a piping system that A. duplicates or replaces without significant change a system operating with a successful service record. Meaning that if you are replacing piping in a system in which the design conditions remain the same, the piping configuration is the same, the piping material is the same, and it is supported, guided, and anchored in the same manner, a formal analysis is not required. B. Can readily be judged adequate by comparison with previously analyzed systems. Meaning that if you are duplicating a similar run of pipe that has already been analyzed and approved having the same piping configuration, piping material, and is supported, guided, and anchored in the same manner, a formal analysis is not required. C. Is of uniform size, has no more than 2 points of fixation, no intermediate restraints, and falls within the limitations of empirical equation 16. Note 8. Note 8. Warning. No general proof can be offered that this equation will yield accurate or consistently conservative results. It is not applicable to systems used under severe cyclic conditions. It should be used with caution in configurations such as unequal leg U-bends or near straight sawtooth runs. R for large thin wall pipe. R where extraneous displacements, not in a direction connecting anchor points, constitute a large part of the total displacement. There is no assurance that terminal reactions will be acceptably low, even if a piping system falls within the limitations of equation 16. Meaning that if there is no change in nominal pipe size in the piping run between the 2 points being analyzed, and there is no other points of fixation or restraint, then equation 16 can be used with the caveat of note 8 being understood. Equation 16 is a simplified way in which to assess whether or not the piping configuration being considered will operate within its allowable stress range. The equation is shown here is d sub y divided by L minus U squared, and has to be equal to or less than K sub 1, in which D equals outside diameter of pipe, E sub A equals a reference modulus of elasticity, K sub 1 has to be equal to or less than 30 times S sub A divided by E sub A. L equals developed length of piping between anchors. S sub A equals allowable displacement stress range. U equals a straight line distance between anchors. Y equals resultant of total displacement strains. The figure in the lower right shows the U anchor distance and the A plus B plus C plus D dimensions that add up to the L developed length of the piping. The Y value is the amount of expansion in inches or millimeters expected to occur in the piping. Flexibility Scenario 2. Paragraph 319.4.2 Formal Analysis Requirements. A. Any piping system that does not meet the criteria in paragraph 319.4.1 shall be analyzed by a simplified, approximate, or comprehensive method of analysis as appropriate. Subparagraph B. A simplified or approximate method may be applied only if used within the range of configurations for which its adequacy has been demonstrated. Meaning that equation 16 just discussed is a simplified method of flexibility analysis and can be used to assess the flexibility of a piping run if the criteria in paragraph 319.4.1 are met. Subparagraph C. Acceptable comprehensive methods of analysis include analytical and chart methods that provide an evaluation of the forces, moments, and stresses caused by displacement strains. See paragraph 319.2.1. Meaning that if analytical and chart methods used can evaluate and take into consideration thermal displacements, restraint flexibility, externally imposed displacements, and total displacement strains, those methods would be acceptable. Subparagraph D. Comprehensive analysis shall take into account stress intensification factors for any component other than straight pipe. Credit may be taken for the extra flexibility of such a component. This marks the end of this excerpt. For more information on the complete course, please contact us at courses@wmhuittco.com. In the subject line, enter Request Info on the Module 5 Piping Design course. Thanks for watching.